And as we have discussed in the topic measurement, and in the last class we discussed about mass and weight, so we'll continue with the same topic, okay, that is your mass and weight. So this is very important. The concept of mass and weight is very important in physics, okay, that's why we are emphasizing on this mass and weight. So last time I told you what mass is, isn't it? What is a mass? Mass is the matter contained in a body. So how much matter is contained in one body defines its mass. So more the matter contained in the body, more will be its mass. Lesser the amount of matter contained, lesser will be the mass. So how do we define mass? Mass is defined as the amount of matter contained in a body. Then we discussed about the SI unit of mass. What is the SI unit of mass? The SI unit of mass is kg. Then we talked about the instrument that measures mass, which is your common balance. So I told you what common balance is, and nowadays it's used by the digital balance. You see those at the shops, isn't it? When you go to buy vegetables or any other thing, you can see it over there where you have to measure the mass. And then I told you one fact about mass, that mass remains constant. So whatever is the mass over here on the earth, it will be the same on the moon, or if you take it to Mars or any other planet or any other place. Okay, so mass remains the same. So these are the 4 facts that you need to know about mass. Now we'll discuss about weight. Okay, what is weight? So if mass is the matter contained in a body, what is weight? So weight is actually nothing but it is a force of gravity. It is a force with which the earth pulls a body towards its center. So anything that goes up, falls down because of the gravitational pull of the earth. So anything that falls down because the force with which the earth pulls any object towards its center is called the weight. Okay, it is actually the weight. So when we talk about weight, weight is actually the force. Okay, it is a force with which the earth pulls a body towards its center. So if I have to throw these 2 objects, if I throw this chalk and a duster, you can see which one has more mass. This one. So if I throw this up, so with which force, the earth, when I throw this up, both up, the force of the earth, that is the gravitational force of the earth, will act on this chalk as well as duster, which means both the chalk and the duster will fall down. Okay, so anything that goes up comes down. So when you throw it up, both will come down. But since the mass of this is more, so what happens is the gravitational force, okay, the force applied on these 2 objects will be different. The force with which the earth pulls the 2 different objects will be different. So it will be the earth will apply more force on the duster and lesser force on the chalk. And because of that, the weight, so more the force means more will be the weight, and lesser the force means lesser will be the weight. Okay, so that's why we define weight as the force of gravity, or the force with which the earth pulls a body towards its center. So if you throw 2 objects, say a stone and a paper, and if you throw both the objects up, it will come down. So with which one will have more weight? Obviously the rock, because the force of earth will be more on the rock. So the strength, okay, the strength that the earth has to apply, the force that the earth has to apply to pull an object towards it depends upon the mass. Okay, so more the mass, it has to apply more force. That means more will be its weight. Okay, did you get that? So more the mass, more will be the weight, because more will be the force to pull the object. let's take an example. Say if you have to pull a chair and a table, so which one do you need to apply more force? Obviously the one which is more heavier, isn't it? The one which has more mass. So you have to apply more force on the table and lesser force on the chair because it is lighter compared to the table. The same way, when the earth applies force to pull object towards it, okay, the more the mass, the heavier the object, more force it has to apply. Thus, the weight of the object will be more if it is heavy. If the object is heavy, it has to apply more force. Thus, the weight will also be more. So, what is weight? Weight is the force with which the earth pulls a body towards it. Okay, with which the earth pulls a body towards it. Okay, so force and the SI unit of weight, the SI unit of weight will be the same as force because the unit of force, the SI unit of force is Newton, and since weight is also force, so SI unit of weight is also Newton. Okay, the SI unit of force will also be Newton. Now, as we said that it is the pull of the earth. Okay, as we have defined it, that weight is the pull of the earth, or the force of the earth on an object. So, the force of the earth, that is the gravitational force, will be different at different places. Okay, so that's why when the gravitational force is different, the weight will also be different. So, weight, unlike mass, will change from place to place. The weight does not remain the same. Okay, if a body weighs 60 Newton on the earth, it will weigh something else on the moon. It will not be 60 Newton on the moon also. If a body, if an object weighs 60 Newton on the earth, then it will weigh something else on the moon. It will weigh lesser on the moon. Why lesser? Because the gravitational force on the moon is less. Okay, the pull, the gravitational force of the moon is less compared to the earth. That's why the body weighs less on the moon. The same body, the same object will weigh less on the moon and will weigh more on the earth because of the different gravitational pull. Okay, so weight changes. That means weight changes from place to place. It varies from place to place because of the gravitational force. Okay, and as we talked about the SI unit of weight, and I told you weight changes from place to place. The last thing, the instrument used for measuring weight is your spring balance. Okay, the instrument used for measuring weight is called your spring balance. And your spring balance is something that you might have seen it, but so you have readings like this over here on a spring balance, and then you have wires coiled like this, which you cannot see. Okay, you have reading over here, and there is a hook here. There is a hook. We suspend, we hang the load here. So whatever, if you have to measure any object, you have to suspend the load here. Okay, this is your load. So it can be any object. So if you weigh this load over here, what will happen? The string will be pulled down. And when the string pulled down, so you can see the reading over here. So whatever reading you see there is the weight. And this instrument is called your spring balance. You have the picture on your book also. You can refer to page number. What would be your page number? That is page number 18. Okay, you have the picture out there and page number 18, figure 1.12. Okay, you can refer to that one. You can see if this picture is not clear, you can see it from there. So you can see the spring coil. You have the spring coil which is not seen, but then there is a hook. When you hang something on this hook, the spring is pulled down because of the weight of the object. And when the weight of the object pulls down, the reading is seen here. And whatever reading you see, that will be the weight of this object. And that is how a spring balance measures the weight of an object. Okay, so I hope you understood the difference between weight and mass. So what is a weight and what is a mass? So mass, okay, so mass, now we talk about, what will we talk about? We will talk about the differences. Differences between mass and weight. And mass is defined as the matter contained in a body. And what is your weight? Weight is the force with which the earth pulls an object or a body towards its center. Second difference is mass is constant. It remains constant. That means it does not change. No matter wherever you take it, it remains the same. The value of the mass does not change. Whereas weight varies from place to place. And why does weight vary? Because the gravitational force of the earth is different on different places, and also on different planets have different gravitational force. That's why weight changes from place to place. The third one is the SI unit of mass is kg. That is your kilogram. So mass is measured in kg, and the CGS unit, the smaller units are gram, milligram, centigram. Okay. Whereas for weight, since weight is the force, so the SI unit of weight will be the same as force. That is Newton. Newton, capital N, you know that, right? I told you in the beginning only, when we are writing units taken after the name of the scientist, then the first letter is written in small and the symbol is generalized with capital letter. And the last one is the instrument used for measuring. Okay, instrument used for measuring is beam balance, whereas for weight is measured by spring balance. So these are the four differences, these are the four major differences between mass and weight. Okay, so these are the ones, and you can refer to this one as when we discuss about the differences between mass and weight. And the major difference between mass and weight is mass remains constant and weight changes from place to place. Okay, so the unit of mass and weight is discussed over here, and we will not get into that relationship between Newton dying, which might I don't know if it's there or not, but you might be reading it in your higher classes. Anyways, we can just discuss it. So, when we talk about the SI unit of weight, the SI unit of weight is Newton. The smaller unit of weight, okay, the smaller unit of mass is smaller unit of mass. Smaller unit means CGS unit. Okay, the smaller unit of mass is gram. The smaller unit of mass, that is your CGS unit, is gram. Okay, and the CGS, that is the smaller unit of weight, is dyne. Okay, it's again named after a scientist, dyne. And the relationship between Newton and dyne is mentioned there. Okay, the relationship between Newton and dyne is 1 Newton is equal to 10 to the power 5 dyne. So when we talk about force, lesser amount of force, okay, when we talk about force, like if we are talking about force for this one, so we use smaller units. For smaller object we use smaller units. So we use here dyne. And this is the relation between Newton and dyne. So 1 Newton equals to 10 to the power 5 dyne, which means 1 Newton is equals to 1 lakh dyne. 10 to the power 5 means how many zeros? 5. Okay, so these are the relationship between Newton and dyne. These are same. This is given in terms of power, this is just written in terms of zeros. Okay, so instead of writing 5 zeros, we just sum it up and we just write it in terms of power. So there is another unit for other unit. Okay, the other units of weight is kgf or gf. And what does kgf stands for? Kilogram force. kgf stands for kilogram force. And gf stands for gram force. So kilogram force, if the weight is given in kgf and if you don't know how to convert it in Newton, then please know that 1 kgf is equal to 9.8 Newton. Precisely it's 9.8 Newton or rounded up to 10 Newton. So either one will be correct. You can write 9.8 Newton or 10 Newton. Okay, either one will be correct. So these are the relationship between the units, the various units. So relationship between Newton and dyne is 1 Newton equals to 10 to the power 5 dyne. And there are other units, okay, which measures weight as well. So other than Newton and dyne, the other units which measures weight is kgf, or if for smaller weight is gf. Okay, kgf stands for kilogram force, gf stands for gram force, and the relationship between kgf and Newton is 1 kgf equals to 9.8 Newton or 10 Newton. Okay, and the relationship between dyne and gf is 1 gf equals to 980 dyne. So these are the relationships that you need to remember, and these are very important when you are doing numericals. Okay, when you are doing the calculations. So these are the values and these are the relationships that you need to remember. So next thing that we're going to discuss in the next class would be relationship between mass and weight, and then we already discussed about the difference between mass and weight. Then we'll talk about density. Okay. So this much for today, and please do revise, and if there's anything, any doubt, please do contact me, and in case of doubts you can call me, and if you want me to explain it again, please do tell me. Thank you and have a good day.